Imaging the sun has been a lot of fun through my Lunt 40mm dedicated hydrogen alpha solar telescope. Viewing prominences, sunspots, filaments, and flares has been pretty amazing. However, the sun has been cut off from my imaging through my ZWO cameras. Hi, my name is Eric. I'm an amateur astrophotographer, and let's talk about why the sun is being clipped from my ZWO imaging cameras. Before we go in this episode, never point a telescope, finder scope, or guide scope directly to the sun without a proper solar filter that is undamaged and approved for looking at the sun. Damage to your eyes will be instantaneous and most likely irreversible. Stars emit light across a range of wavelengths in the electromagnetic spectrum. Our sun produces electromagnetic waves in the form of gamma rays, X-rays, ultraviolet, visible light, infrared light, microwaves, and radio waves. Most humans perceive wavelengths in the visible spectrum through the eye using special cells called photoreceptors that turns light into electrical signals to the brain. Since the sun is producing the entire range of light across the visible spectrum, the sun appears white in the sky despite it peaking at 500 nanometers in the blue-green wavelength. Solar telescopes like the one that Lunt offers uses specialized filters to allow only a very narrow band of wavelength through. The red hydrogen alpha is 656.28 nanometers. It gives us a view of the solar chromosphere where all the action is at: sunspots, filaments, prominences, flares, and more. Looking through my Lunt solar telescope offers some pretty amazing views of our star through my eyepieces. Here's what that looks like through my 32mm Plossl eyepiece using my Google Pixel 8 mobile phone. The image is challenging to capture with a cell phone, but it is an amazing sight. When I purchased my solar telescope, I purchased everything with the idea of portability and ease of use. I got the reliable Skywatcher SolarQuest Alt-Azimuth solar mount and the ZWO ASIAIR Mini Astronomy Wi-Fi smart device to take images through my astrophotography cameras. The first camera I used was the one I was using as a guide camera for my telescope, the ZWO 290mm mini camera. And although it takes some great images, the camera could not get the whole sun on the sensor. The angular diameter of the sun is approximately 1/2 degree or 32 arc minutes. The field of view on the ZWO 290mm camera is at 0.8 degrees by 0.46 degrees. So my images of the sun will always be clipped. Here's an example of one of those images. So as a solution, I took 2 images of the sun and I stitched them together through Adobe Photoshop. And here's an example of that. So since ZWO has upgraded their 290mm mini camera to the 220mm mini camera, I went ahead and purchased that camera for both my guide scope and Lunt solar telescope. I recently used this camera for the 2023 annular eclipse of the sun. Between lots of clouds, the 220mm mini camera did a pretty good job at imaging the sun that day. But I noticed that the images were not the same quality as the 290mm mini camera. The issue I discovered was that the camera is slightly undersampled. So what is sampling? Beyond getting a free meal from some small trays at the local wholesale clubhouse, it is an important consideration in photography. Sampling is the process of converting an analog signal into discrete values that can be recorded on a memory chip. In digital photography, this is all being done through a photosensitive computer chip and the associated hardware and software. A properly sampled image is sharp and is properly resolved. An undersampled image is lacking information or signal from the source. It generally looks too pixelated. The pixels on the chip cannot resolve the details of the image. Stars become blocky and lose their roundness. Here's an example I created with one of my images to look undersampled. Notice how the details of the moon are not quite adequately captured. The edges are jagged into squares or rectangles. An oversampled image is where the signal or light is spread over more than one pixel. The pixel size on the image chip is small enough that the light or photons are spread over more than one pixel. As a result, it could take more processing time for the camera and possibly result in a soft image. Having a properly sampled image is an important consideration when purchasing astrophotography cameras. Pairing the right pixel size of your camera with your telescope's focal length for the seeing conditions will result in proper sampling. This subject is pretty deep and we can easily get lost in math formulas and charts, so to make things easier, check out your camera's pixel size. Then use one of the available online calculators to see if you're going to get good sampling size with your telescope. Astronomy.tools has a calculator to help out with this. Select the CCD suitability calculator and use the drop-down menus to match your telescope with your camera or the one you're planning on purchasing. It will tell you if your pixel size is adequate. So after checking astronomy.tools and the online reviews, I purchased the ZWO ASIAIR 178mm monochrome camera. I did an unboxing video on this summer. This 6.4 megapixel image sensor has a large array of pixels at 3096 by 2080. This gives the 178mm camera a field of view that is 1.06 degrees by 0.72 degrees, more than adequate for our sun that has an angular diameter of 0.5 degrees. The pixels are at 2.4 microns in size, which is perfect for the sun and moon. High quantum efficiency, fast frame rate, and back illuminated. With my camera loaded up on a sunny day in my Lunt Solar Telescope, I begin imaging the sun by using the Lucky Imaging technique. Lucky Imaging is where you use the video feature of your astrophotography camera to take a high number of short exposures so that it minimizes the effects of Earth's atmosphere. In post-processing stacking, only a small percentage of those exposures are stacked, providing a sharp and crisp image. As I used my ZWO ASIAIR Mini Astronomy Wi-Fi smart device through my old iPad, something was wrong. A portion of my sun was clipped, and no matter what I did, I could not get the entire sun in my image. You may find that your solar images are being clipped as well, so let's review what could be the issue. First, is it the blocking filter? My Lunt 40mm solar telescope came with the B600 blocking filter. The filter is 6 millimeters in diameter. Lunt recommends this blocking filter with telescopes with up to 400 millimeters in focal length. They do recommend a larger blocking filter as some astrophotography cameras need it for the back focus. Be sure to check out Lunt's website for more information. 2. Is it the astrophotography camera? By checking the specifications of my camera and using astronomy.tools, my 290mm sensor is too small for the sun. But my 220mm and 178mm camera are large enough to capture the sun. And 3. Is it a hardware issue? I've been using the ZWO ASIAIR Mini Astronomy Wi-Fi smart device to take my videos. The ZWO website says that their devices support video mode, but I could not find any more details. Thanks to subscriber Bart Sidali and ZWO customer service, the entire line of ZWO ASIAIR astronomy smart devices are limited to 1080p mode. This means that the smart devices cannot use any pixels outside an area of 1920 by 1080. This means for me that only 1/3 of my camera chip is available. So if you have the ZWO ASIAIR Mini, 32GB Plus, or 256GB Plus devices, we are limited to the 1080p mode due to hardware limitations of the devices. This is unfortunate, and I hope that ZWO is able to update this device in the future. If you want to take advantage of the full features of the ZWO 178mm camera or any other astrophotography cameras with an image sensor larger than 1080 pixels, you will have to use a laptop computer and imaging software such as the ASIAIR Studio, SharpCap, Fire Capture, or Nina. With my laptop, I was finally able to get a full image of the sun with my ZWO 178mm monochrome camera and enjoy the details of our star. I hope this episode has been helpful. If you haven't subscribed and you're interested in learning more, be sure to smash the subscribe button and give me the thumbs up. Until next time, clear skies.